Hey everybody, this is Larry. This is me going over Q3 of the Leetcode weekly contest 225, find kth largest XOR coordinate value. So this one actually was my easiest problem. I actually solved this one even faster than Q1. So hit the like button, hit the subscribe button, join me on Discord. My energy is a little bit low today because of some life events, but I'm okay. Don't worry about it. But just let you know. So I wish that they just have one example in terms of like one diagram. This would make the problem much easier to read. But basically, you have the idea behind this problem is that you have some matrix where it's like 1 2 3 4 5 5 6 7, I don't know, right? I'm just putting a random number, and the idea is that given for a given cell you want to, and it's hard to let me make this go a little bit bigger. So basically, you take the rectangle that starts at the corner of 7, which is basically 1 2 3 and 5 6 7, and we take the XOR sum of that, right? So one thing about XOR sum is that you could, and this is what I would say is that when you practice, you know these properties of XOR that you might not, and if you don't know about it, then this is just what practicing and figuring out and solving problems mean. And I would say also, if you have an issue debugging, what I would do is, instead of using the XOR function, I'll use a simple addition like this, and then because after you do this, then you could print out the matrix to see where you're wrong. Like if you have an off by 1 or something like that, then you could use that to figure out what your issues are. But the idea here is that this is a prefix matrix, and basically you're trying to figure out the sum from the corner to that point, and that is a dynamic programming problem. I think there's definitely prefix matrix sum. Let me see if I can find a video on this that's good. My computer's a little bit slow right now. Apologies, hang on. Technical difficulties. But yeah, but yeah, I would call this a prefix matrix. The Wikipedia article is not great on it, but the idea is that this is the recurrence, and to be honest, it's not like that I've seen it before, but I know how to do it for regular sum, as I was saying, because I've seen it, or seen that version of the problem multiple times, and it's even used for other things that are helpful. Because you can figure out other sums that way. But for this one, as a result, that's the way that I write it. I think there are different ways to write this recurrence, but this is the way that I write it, is that I do it row by row first, and then I do it for each column, going for each cell. And once we do that, at the end of these two loops, we should have a matrix where the value at that point is equal to the matrix, the XOR sum, if you will, of all the rectangle that starts before it. And actually, you can, if you really want to test your limitation and upsolve, you can figure out how to do this to get any rectangle inside the matrix, and not just from the upper left corner. But yeah, once you do that, I put everything in an array, I sort it, I reverse it, and then I return the result. You can actually, so the key, so this is going to be, given R equals to rows, C is equal to columns. Obviously, the two for loops are straightforward to understand. It's going to be linear in terms of the two for loops, but we do have a sort all these items, so it's going to be O of R times C. Why did R plus C? Sorry, R log R times C. Because that's the number of elements. So you can think about, if n is equal to R times C, then this is just n log n, because we have to sort all of them. And in terms of space, because this array is going to take, O of n space, because it has 1 for each element, right? Yeah. So that is the complexity I have. So there is a way to upsolve this, to use k to kind of take advantage of that, where we can actually limit, the space to O of k, and we can limit the time to O of n log k. And this is actually, I didn't do this during the contest, so I would have if I had to, depending on the constraints and how much time I have. In this case, it turns out to be okay. Oops, not this one. A million. So a million log n is fast enough. But the way to do it with the k is just by using a heap. So that you only keep track of k elements at a time inside the heap, and you push a new element to the heap. So it takes log k time every time you iterate. Let me actually put these together. I'm not going to write the code. Definitely left as an exercise for you. That, to be honest, that is actually very required. So like, if I was on an interview, I definitely recommend doing this with the heap because they'll definitely ask you about it, and it's definitely expected if they're going to ask you about this. And even if not this, for similar problems, top K or whatever, that's going to be something that you definitely need to know. For me, I just wanted to solve it during the contest as soon as possible, and I think I solved this in about 2 or 3 minutes, which was my fastest solve for this contest, as I said. So I didn't really want to think about it. That's pretty much why. Yeah. Thanks for watching, and you can watch me solve it live during the contest next. I'll come back to it. People probably already finished the contest. Wow, I am just really out of it. You're given an interview, okay? The cave largest corner. I feel like one diagram would have been clear about it. Is it just so all matrix okay, so basically like the quadrant. Seven 240. Okay, 7540. Okay, that sounds right. Oh, oops. 045. Oh, oops. 7540. Let's see if it's too slow. I can't believe I solved that one in like. Hey everybody, thanks for watching. Thanks for checking out this problem. Let me know what you think. Let me know what you're running into, and I will see you hopefully next time. Bye bye.